All right, guys, welcome to Algebra 2, 5, 2, 3, and today we're going to be talking about logarithms again. So it's a bit of a different type of section today. I don't do what the book typically would have you do, so I do kind of my own thing here. So what I want you guys to do is go ahead and first just kind of answer these first 5 questions to yourself. So think about those for a bit, and try and answer those. Once you're done there, what you're going to do is the bottom portion here, which is you're going to first think of your own value of like b. So b can't be 1 and it can't be 2. So any counting number that is 3 or like higher, you can pick whichever one you want and make that your b. So b being the base of our logarithm like we have here. So once you have that, you're then going to make an XY table for it, and you're only going to want to use the easy values there. So those are the ones which we did the last time, which you saw, which gave you nice, pretty non-decimals, so you didn't have to do any of that kind of guess and check. So think about what kind of values of X would give you those particular easy, pretty things to plug in. Then, once you have that made, and I'd say pick like 6 or like 7 different points to have there. Once you have those, then make the inverse table for that. So again, our inverse tables, we just transpose the x and the y values on our table, and then we have the inverse table. Then I want you to sketch both of those on the same graph from the table. So don't use Desmos or a graphing calculator to do that. Use the tables you just made. And then finally, take your equation with your like log base whatever of x and rewrite that in exponential form. So use the kind of rules of converting back and forth that we've gone over for the past few times. So go ahead and pause the video, try that out, and then come back here and we will do one together. All right, so we're going to go ahead and try this out. So we're going to do y equals the log, we're going to do base 5 of x, just because you likely didn't choose 5, so I chose 5 to make it a little bit different. So we're going to make our xy table here. Now the values which work nice for me and make it nice and pretty are values that are not multiples of, but powers of 5. So easy ones would be like 5, right? 1. I could do 25. I could do 125. And I could keep on going that way, but I do want to go in the fraction direction too. So I know that 1/5 works out well. That's 5 raised to the -1 power. I can also do 1/25 and also 1/125. So I had those be my x's. Now the y's which correspond, well, I get 1 from taking 5 to the 0 power. You get 5 from 5 to the first power, 25 from 5 to the second power, 125 from 5 to the third power. And I get these fractions by just the negative powers of those same things. So that would be my table for log base 5 of x. And I could plot all of those and see what it looks like. So now for my inverse, I'll do negative f of -1 of x for my inverse. When I graph that, or sorry, make the table for it, I literally just transpose my x and my y's here. So I have -3, -2, -1, 0, 1, 2, and 3. And then I have 1 over 125, 1 over 25, 1 over 5, 1, 5, 25, and 125. So there's my table there. Now, I'm not going to bore you by making you watch me plot points, but what you should see when we plot these is our original will cross through at 0, 1, and then we have some points down here, and then we kind of do that number. So we end up with that kind of shape. And we've seen the shape in the past, that's our shape for the logarithmic graph. Right? So you kind of follow the asymptote on that vertical axis, and then you kind of cross over and then go right really, really fast. Now the inverse will cross at 0, 1, and it follows this asymptote, and then it curves up and goes up really, really fast. So you get that kind of a shape out of it. And what you should notice, like you've done in the past, this is a reflection over the line y is equal to x. So it's reflected over that line there, which again makes sense because they are inverses. So one of the big things that I wanted you to kind of notice here was that all of the past few times we've done this, we always give you the exponential as the original and the log was the inverse. So the log was the inverse of the exponential. But consequently, the exponential is the inverse of the logarithm. So this is true for all inverses. They're inverses of each other, right? So I wanted to kind of see that here, and let's kind of also get a little bit more practice on working with these logarithms. All right, let's hop back over to this. And finally, I want you to kind of think about real briefly, what parts of logarithms do you feel comfortable with? Do you kind of get now? And then what parts still kind of are messing you up and making you kind of struggle with them? So think about those, and then that'll be it. And here is our homework for tonight. We're doing 84 through 92, and I'll talk to you guys next time.